Hello and welcome to this first lab of fall 2024 semester for Introduction to Operating Systems. We're looking at this lab that is not really related to operating systems. However, this lab is a way to serve as a primer slash transition for Python programmers into C. Firstly, Python is a scripting language. It is interpreted. It is very different from how C functions as a language. C is a compiled language where a source code is first compiled and converted into machine code, and that executable program is then loaded into memory. And that's how C programs run. Whereas Python, you interpret everything line by line. There's more differences in C. The main differences that we're going to notice in this course is C has a lot more control over system memory and things like threads and multiple and parallel processing. So essentially, the implementations that exist in Python that have already been implemented by some people, while they have been implemented in C or Java, if you use Jython, it is difficult to do the same implementations in C because the lack of those implementations. C is a very bare bones language, and that makes it so that you have a lot more control over things that you're doing, but it also means a lot of the functionality is not inbuilt. You might find libraries or things that you might load into your language. However, out of the box, C doesn't have the functionality that Python may have. But essentially it provides you with this another aspect that you have control over system memory and other things that you might not be able to control when using Python. So let's go ahead and look at this linked list labs and then look at some things that are implemented in C that might not be in Python. And I'll go ahead first explain the linked list in a visual condition, and then I'll come back and we'll solve the create node function together, and hopefully that'll give you enough of a starter pace or a base function to be able to continue the next functions that we have provided over here. So let's go ahead and look at a linked list first of all. What is a linked list? It's basically an iterator of multiple data types that you can iterate once. So essentially, when we visually look at a linked list, we look at something like a node or a data, and the data contains a link to another data point, and essentially this keeps going on till you reach the end. And sometimes we have a linked list that's doubly linked, so you know what's in the front of it as well as what's behind it. But let's focus for now on singly linked lists. So essentially in Python, what we have is a list. So we're gonna have something like some data over here. Let's call it 24, 32, 29, 10. And essentially when we go through a list, we have our first, our second, our third, our fourth elements, and we're able to iterate through them through for loops and other things like that. And we don't really have to worry about the parts that are these links over here. And essentially, that is because Python implements those links for us. However, C does not implement those links. And how those links are implemented is a little different. So let's go ahead and look how the linked list works in C. So let's imagine a workspace of memory with different memory addresses. So essentially, we have memory addresses that are 20 apart in hexagon, and we have these memories. Essentially, what we're going to do is let's go back to the code and let me show something over here. We have a structure. A structure is nothing but a class. However, a class has data types as well as implementations slash functions for the data type. So essentially, if you have an int and then you have a bunch of functions or implementations that you can do to manipulate that data. A structure is nothing but a data type that you create yourself. It's a user defined data type. So essentially, you can create structures that contain multiple data types. So essentially, you could create a structure user, and that could contain something like char username, char user ID, char user password, and that is just one data structure that holds all that memory. So essentially, you don't have to keep worrying about different variables. And once a structure is created, you can access that structure, and the structure itself within it contains all these pre-implemented data types. So essentially, we have a structure node over here. And inside the structure node, we have two things. We have a variable data of type int, and then we have a pointer called next of type node, and that is a structure. So essentially, let's when we create a node, we're going to have, let's imagine this is our node. When we create a node, we're going to have two partitions. One is our data, which is of type int. So we have that. And then we have the pointer, which is of type structure node. So that is our pointer. And what are pointers? Pointers are basically addresses. So essentially, we're going to have an address over here. And so when we create this node, we're going to list it in a way. So let's imagine us creating a node, and let's call this head node. And essentially, we want this head node to have a value of 24, and then we're going to have to provide it an address. And so we're going to provide this an address of 0x1920. So essentially, this node gets put in memory over here. And so we have at 1920 a structure of node that we've defined, and it contains a data 24, and it contains and it contains an address. And essentially, because we have a linked list, we have an address right now because we have nothing next in the list. Because if you remember from our thing, we have a pointer that is named next. So this pointer is essentially what holds what's going to be our next link. So essentially, this next part is holding our link, our arrow. So in this right now, because we have no other links, we just put null. And essentially, when we put null, when we access this, we know that this is the only node in the memory. However, let's go ahead and add our next node. And that next node is going to have a data type. So our data of type int, let's say that's 30, and we're going to have an address. And this is the address of the allocation. Let's say, hypothetically, allocate this to a memory or the address 1940. We have over here, our data is 30, and then we will have an address. However, when we're doing this, we make sure that our previous node, we connect this to the next node. And how do we do that? This pointer, this address in our node structure, we're going to erase this null, and we're going to set this as this address 0x1940. So essentially, and then because we have no more links next to this, we're going to put the address over here as null. So essentially, when we access our linked list, we access the head node, which is over here at the memory address 1920. At 1920, we can see we have a integer that is 24, and then we have an address which is 1940. And this 1940, when we access this memory, we go over here, we see we have another structure of type node that we created, and this node structure is going to be another node. And essentially, when we create another node, let's say that node got added at 1960, we have 10 over here, and then we have nothing next to it. Essentially, when we add this node, we make sure that we erase this null and make sure that our next is pointing to the address 1960. So essentially, when we access 1960, when we access this address, we can see that we have a structure node over here. And let's put 1960 over here. And essentially, that's how we create these links in C. And we are creating these arrows that point to memory addresses. These arrows that I'm pointing with blue, we're pointing to memory addresses, and that's what a pointer is. It points to a memory address. And when we access that memory address, we can see what the content of that memory space is. And when we see what the content of the memory space is, we have a structure node. And then we can access that structure node. And let's do a little recap. So essentially, if this is our node, it is of type structure, and we've called this structure node. Inside the structure, we have an int, and we have an address. And the address is our pointer. Our int is going to hold whatever data that we want. And then our address is going to hold the memory address of where the next node in the link is. So essentially, if we were to look at it as a linked list in Python, something like this, our blue is the data and red is our link. And that's how linked lists are implemented in C. And that's how we saw visually. Now I'm going to go ahead back to the code, and we're going to have, let's go ahead and I'll help you implement this create node function. And let's go ahead and implement this. Look at the steps, see how we're going to implement this, and then the next functions you can implement by yourself. So first step says we need to allocate some memory for the new node. The program doesn't know how much memory is needed, so we call a function malloc. Malloc stands for memory allocation, and we need to malloc, we need to pass in what the size, what amount of memory we need. So essentially, and secondly, while I'm over here, C is a statically typed language. So in Python, if you wanted something like var name1, and this was a variable, we could essentially just assign something like my name over here. and that would work. And Python is a dynamically typed language. The interpreter looks at it, it goes like, this variable var name1 is of type string, and it assigns it type string. However, C is a strictly statically typed language. So essentially, when we declare a variable, we need to make sure we give it a type. So essentially, if we are looking at this data over here, we have a variable data and we have assigned it a type int. Anytime this data is allocated something that is of not type int, the compiler will throw an error, be like, that is not correct. The variables data type will not change, essentially. So we're gonna go ahead, and the first thing that we need to create our new node is to create a variable that'll hold the new node. So our variable name is going to be new node, and where the new node is going to be equal to something. The new node is going to have a data type. Our data type is going to be a pointer of type structure of a node structure. So essentially we have a pointer of type struct node, and the name of that pointer is new node. So let me highlight this. This is our data type. The star represents a pointer. The pointer is of type struct node, and the name of this pointer is new node. And what we now need to do is allocate some memory. So we need to do a malloc. This is a function call. We call the function malloc. What do we need to pass into malloc? We need to pass in how much memory we need in the system to create this new node. So we call another function called sizeOf, which will tell us how big or what the memories or what the size of our particular whatever we pass into. So if we did int, it would give us back 8 bytes. If we did char, it would give us 1 byte. But we need a memory allocation of the size of this structure. So essentially we pass in struct node, and essentially it's going to look at a node structure, see how much memory that needs, allocate that memory, and we terminate it. But malloc by itself will return a pointer of type void. So when malloc sends it back, it's going to give us a generic pointer of type void, and that could be anything. However, because it's strictly static type in C, we know what the type of our pointer should be, which should be of type struct node. And so our pointer is going to be of type struct node. So essentially this, let me highlight this again. We have a memory allocation function. Inside the memory allocation function, we call another function sizeOf, and we're passing our parameter struct node. SizeOf calculates what the size of structure node is. That calculated size gets passed on to memory allocate, and that memory allocate allocates some memory and gives us the pointer to where that memory is. However, it gives us back a generic void pointer. However, because we know what our pointer should be, we assign it a type of struct node. So essentially this is nothing but this part is equivalent to this part. We're just assigning the pointer that we're getting a type. And that is our first part. And let's go ahead and see our second part. In our second part, we need to check if the memory allocation was successful. And how we do that is we need to check if our new node has been created. So if new node is equal to null, that means we don't have any space where the memory was assigned. What we do is nothing was given to us, so we return null and we say that the memory allocation was filled. And essentially, if it's not null, we move on to step 3, which is initialize the node with the data and we set the next part to null. Because this is the last node that we created, we set it to null. And essentially, when we iterate through the list, we can update which address should go inside the next, which address the structure should hold. But for now, all we know in this function is what our data is. So we're going to set the data to data. So our node is called new node. We call that new node. Inside the new node, we call the data. Because the structure has two types, data and the pointer, we assign the data part data. And so essentially this is going to be putting in over here. And this part is going to be this. I should have named it better, probably user assigned data, but essentially what this means is this gets passed to this function, and so a structure new node whose first part, which is integer, gets data, and we assign whatever our function received to the node's data. And then second part, we need to also assign what our address part is going to hold. So new node next. So this is our pointer. What this is going to hold for now is null. And we can change it later and you'll see how you will do it. So essentially we put in null over here, and then because and let's see over here that we need to return what we got, and returning is weird. So what we return in this function, the function should return whatever its data type is. So we have a function of type struct node pointer, so we should return something that is of the same type. And so we're going to return our new node. Our new node is of the same type as this, so it's returning. Static is just a keyword that is used for used for something that I will explain later so that it doesn't confuse you guys. But static is just a data type. It helps in assigning functions a okay, no, I'll tell you what it does later. But you can ignore this part. It doesn't affect your code in any way. But essentially we return our node, and then this was just a placeholder statement, so we can go ahead and remove that. A function should only have one return statement where it returns whatever the function type is. And hopefully this video was well informative for you guys. And now you guys can go ahead and implement other functions in this code. There's enough steps and hints given that will help you, and all the best. Thank you so much for watching.